In this video, we'll take a look at how we can use the line segments between corresponding points of transformations to determine whether that transformation is a rotation, a reflection, or a translation. So looking at this diagram here, it's nice and it's labeled parallelogram x, y, z, w, and parallelogram x prime, y prime, z prime, w prime. So they've labeled these points for us already, so we know which one is the original pre-image, which is x, y, z, w, and which one's the transformation x prime, y prime, z prime, w prime. So, to determine whether this is a translation, rotation, or reflection, we'll draw line segments between the corresponding points. So x corresponds with x prime. Don't know why that popped up like that. Let's try it again. There we go. Y corresponds with y prime. Z corresponds with z prime. And w corresponds with w prime. So after we connect all of the corresponding points with line segments between the two images, we notice that they're all parallel and they have different lengths. So when you have parallel lines, but they're different lengths, this is what we look for in the transformation called reflection. And using these lines we've created and using what's called a perpendicular bisector, you can actually calculate the line of reflection. And if you'd like to learn about that, let me know, and I'll put that in a separate video. Otherwise, you'll deal with that in later math courses. Let's see what the next one is. The next one looks like this. So this one's a little bit different. We have two shapes labeled A and B, but they did not label the corresponding points for us. We'll have to look at this carefully and determine our corresponding points. So I'd probably start with this one right here. This one's pretty easy to see. It's at this V right here. So over here, that's this point right here. I'll label this point W. I'll call this W prime. I'll assume A is the original pre-image and W is the image. And now I see it goes off in two directions. This line segment here is shorter than this one. So I'll call this point WX. This line segment here is shorter than this one, so I'll call this point X prime. And we can actually stop here if we want to. You can start playing connect the corresponding points game. Get my straight edge out. Because in a situation like this, you're going to notice something. There's W to W prime. And here is X to X prime. These two lines are not parallel. If the corresponding lines are not parallel, then there's only one option for a single transformation. That's going to be the rotation. So this is a rotation. So B is a rotation of A. And again, if you want to use a perpendicular bisector, you can find that point of rotation. Although we can see that point of rotation right there, actually. And if you'd like to learn more about how to actually calculate the point of rotation, let me know. I'll put that in a separate video. But you can use these lines between corresponding points to just quickly determine whether it's a rotation, a reflection, or a translation, which we've not yet gotten to. So let's take a look at what that will be like. So here is the last one. Again, these are not labeled as to which one is the pre-image, which one is the image. Not that it matters for identifying rotation, reflection, or translation. So we'll go ahead and label these. We'll say that the blue is our original. We'll call this point X. And I notice that down here, looking at the line segments and the angles, I can see this is the longest side, so the longest side's opposite the point. This side is shorter, this side is shorter, so this point right here would be X prime. Shorter side coming down, I'll call this point Y. That'd make this point Y prime. And then this would be point Z. That'd make this point Z prime. And now when we play connect the corresponding points, we'll connect Y with Y prime. There's that. We'll connect X with X prime. And we'll connect Z with Z prime. And then we notice that the lines are not only parallel. So we have parallel line segments. They're also congruent. Congruent. The symbol for congruent is an equal sign with a similar symbol on it. Parallel is just two lines up and down is the shortcut symbol for parallel lines. So if the corresponding lines, or sorry, the lines between corresponding points are parallel and congruent, we get a translation. If they're parallel but not congruent, it's going to be a reflection. And if they're not parallel, that's going to be a rotation. So that's one way of determining whether it's a rotation, reflection, or translation when you have a transformation. And you can use these line segments to get more information about the translation, rotation, reflection. If you'd like to learn about that, let me know and I'll put that in a separate video. Thank you for watching.